My name is Nuno Gomes. I am an astronomer working at Nucleo in Portugal, and currently I'm talking from the beautiful city of Nairobi in Kenya, and I will be your host today. Joining me is Matt Brealey. Hi, Matt.
Hi, everybody.
Matt is a freelancer living in Bristol in the UK. Who is using tools and techniques from the visual effects industry to process raw space data. His goal is to make entire mission datasets accessible to those without technical knowledge of the projects involved. Is that right, Matt?
That's very true. You got that spot on.
Okay, thank you so much for accepting our invitation. It's a privilege having you with us today.
That's fantastic to be here.
Cool. So Matt is going to talk about how we approach processing 2D and 3D data from planetary data systems and individual mission outreach websites like UA High Rise, I don't know if I'm saying it correctly, and Mission Juno, is that right? In order to create two web-based applications named Aerial Browser and Juno Observer, right?
Yeah, that's right.
Okay, those applications will allow users to explore the HiRise DTM and JunoCam datasets in full 3D. Matt will explain that better later on. We'll also discuss the tools used in the upcoming open source visualization of the Kepler exoplanet dataset, which will be accompanied by an online tutorial series. At the end of the presentation, of Matt's presentation, we are going to have a Q&A session. So please, if you have any question you would like to ask during the presentation, use the dedicated app or the chat window available in the Zoom to write down your questions. And then Matt will be glad to answer all of them, okay? So I think we are ready to start. Matt, you have the word.
Fantastic, thank you so much. Okay, I'm gonna share my screen and share my desktop. And hopefully, maybe Nuno, you can just tell me you can see this. That'd be good.
Yes, I can, yeah.
Fantastic. So let me just move this chat window off to the side. So hello, everybody. So as Nuno said, my name is Matt Brealey. I've spent a lot of time doing visual effects work because I am not a scientist. That is the key thing to know about me. A lot of people on these webinars, like Nuno himself, are planetary scientists and work on the missions involved or work with the separate data sets. I do not do that. I never studied science. I didn't even go to university, believe it or not, although you definitely should. My background is in the visual effects industry. I worked here in the UK. I worked doing kind of film and television and commercial work for numerous different companies here in the UK. And today I'm going to tell you how I've been approaching processing of raw space data using those techniques that I learned from the visual effects industry. Now, the key thing that I want to say up front here is that there's a lot of ways to visualize data. There's a lot of ways to process data. What I'm going to show you is through the lens of what I find really interesting and through the skill set that I have. If you watch this and you have no interest whatsoever in coding, in the creative coding that I'm going to show you, that is absolutely fine. If you do want to learn more, I'm going to give you some links at the end. But if you have no interest in coding, there are plenty of other completely valid and exciting ways to visualize space data. To give you an example, I cannot paint, I cannot draw at all. I am completely terrible at it on every possible level. There are plenty of people that I follow online who can and do wonderful, wonderful things, wonderful visualizations with different aspects of space data that I would love to be able to do but can't. So this is just looking at the stuff that I find really interesting and the things that I can do with the skill set that I have. So that being said, there's lots of things to talk about today. So let's go to our next slide and I'll show you a little bit of what I'm going to be looking at. So first of all, I want to explain what actually is raw space data. What does that mean? Why is it better than just space data? What does it mean to work with it? Why is it better? Why is it worse? After that, I'm going to look at the two visualizations that I've done over the last kind of year and a half. One is Aerial Browser, as Nuno mentioned, which allows you to view different little tiny 3D slices of Mars, basically, in your browser or on your mobile phone. The second one is Juno Observer, which allows you to see images from NASA's Juno spacecraft, again, in 3D in your browser. Once I've done that, I'm going to take a look at how you could potentially get started processing raw space data yourself, whether you're interested in looking at it from a creative coding point of view, or whether you're looking at it from an artistic point of view. I've got a couple of options of things that you could potentially do. I'm then going to look at the next project that I'm going to work on, something called the Kepler visualization, which is something that I really wanted to do for myself, but realized would be quite good to share with other people and share the process with other people. So I'm going to be talking about that too. And then finally, as Nuno mentioned at the end, there'll be a bit of time for some questions and answers. So as I said, if there's anything throughout all of this that you have any questions on, just do write those in the chat and we can always answer those at the end. So to begin, let's talk about raw space data. What actually is it? Well, in a nutshell, in its simplest form, raw space data is data exactly as it was captured by the camera, by the spacecraft, by the orbiter, by the rover, by NASA InSight, which landed last night, which was amazingly exciting for everybody. It's data exactly as it was captured. And that comes with good things and bad things. You tend to have a higher file size because there's more data involved. And it can also be a bit unwieldy to work with occasionally. It's a little bit similar to if you've worked with a slightly more professional camera, it might have a raw mode on it. And when you're using that raw mode and you take a photo of something, you have more options for how you can play with that photo after the fact, because there's more data involved in that raw image. And I actually have a quick example for that. So this is a shot here of my kitchen, and there's an animation here, and these two shots side by side. Now on the left, we have an image which isn't raw data. This is not raw data. And what you can see is if you look in that middle window around that tree, as I change the exposure of the image up and down, you can see that it just goes completely gray. There's no detail in there. You can't see the clouds. You can't see anything, right? If you look at the one on the right, the raw data version of this image, as that exposure lowers down, we're actually revealing more information. You can start to see the clouds at that point and see that extra detail. And that's the key of working with raw data. There's detail at every level of the image, some of which might not be immediately visible, but that you can pull out. And it's a way of giving you greater control over your image. So in addition to giving you greater control, it does also require a lot of extra processing, which is one of the things that I'm going to be talking about now. So normally it's not just a case of downloading a bit of raw data and having something that looks kind of awesome. You usually have to do things like clean it up. You usually have to get rid of noise, get rid of things that you don't want in there, and just make sure that it is exactly what you want it to be, and kind of create a narrative with it for yourself before showing it to everybody else. So to give you an example with space data, this is a lovely picture of Jupiter. This was captured about 2 months ago, I think. And this is not a raw space image. I know because I processed this myself that the images that come down from the spacecraft orbiting Jupiter that capture this imagery, this is not what they send back to Earth. What they actually send back looks closer to this, which is completely different for obviously many, many reasons. One, it's completely gray, which is very strange. Two, you have all of these weird, spiky, kind of jaggedy bits in it that we're gonna have to try and figure out. We're gonna have to try and understand before we can turn this raw image into that nice picture of Jupiter. So another quick example, this is actually the first bit of raw space data I ever processed. This was probably about 2.5 years ago, maybe 3 years ago now. This is a moon called Ariel, and it was captured during the Voyager mission. And what you can see in this animation is that of these about 20 different images that I've stuck together, there are some which are really nice and some which are very clear. And there are others where there's this kind of static and this kind of noise in it. And there's even on this really good last image here, there's lots of black dots that you have to go and clean up. And that's that extra processing that I'm talking about, kind of filtering out the bad stuff and concentrating on that good stuff and pulling it to the forefront. To give you an idea of how much is available, there are 76,000 images, raw images from the Voyager mission alone. And that was admittedly a long mission. It was for over 10 years, but they're all available for you to browse, to freely download. You can find pictures of moons, you can find pictures of Saturn, you can browse the rings of Saturn, you know, Jupiter, Jupiter's red spot, all available for you to freely download and play with and start processing and exploring yourself. And this is one of the reasons that I started kind of falling in love with playing with raw space data. It gives you this view onto the solar system, which I'd really never seen before. And the idea that it's how it came back from the spacecraft is just amazing, right? So that is our raw space data. It's now time to look at my first visualization, Ario browser. So when I saw this raw space data for the first time, my skill set, what I kind of feel comfortable with, is working with 3D, working in 3D data, 3D models of things. So I wanted to try and find a raw data set that would allow me to do 3D stuff. I didn't really know what it was. I just wanted it to be interesting and to be exciting for me. And what I found is that if I tend to find things interesting, there's probably going to be at least a couple of other people who also find it interesting. And when I was looking around, I found the HiRISE dataset. HiRISE is a camera on board the Mars Reconnaissance Orbiter, the MRO, that is orbiting around Mars. And it takes pictures like these. And these are just beautiful, beautiful images. And they are just, strangely enough, of Mars, which kind of blows my mind every time I see them, because they look exactly like pictures that might be taken, satellite pictures of Earth, right? But it has this cool trick that it does as well. So as it orbits around Mars, if it takes a picture of the same point on the surface from two different locations in its orbit, it can do some kind of complex math and try and figure out the height of the terrain. It can try and figure out the elevation data of the different points on Mars. Now, that data is raw data that is then sent back to Earth, and that raw data looks a little bit like this. This is a black and white image. It's black and white values, really, between 0, which is the black, and 1, which is the white, that represent that elevation, that height of the surface of Mars for this particular image. And what you can see in here is that, okay, there's this kind of strip in the middle. There's a bit darker on that left-hand side than it is on that right-hand side. So dark is low down, white is high up. So maybe there's a slope there in the middle. But this isn't the easiest way of visualizing the data. It's not the best way of looking at it and trying to understand exactly what's going on with this little part of Mars. So there is another visualization that the HiRISE team put together, which looks like this. So in this image, instead of having this single gradient going from black to white, we have this kind of gradient that you can see there in the middle, going from purple through blue, through green, through yellow to red. And red is the highest point and purple is the lowest point. There's a little bit of extra lighting information in here as well, but it's obviously a lot easier to try and figure out exactly what's going on. You can start seeing this kind of strange crater-looking shape in the middle there, which looks kind of interesting. But again, it's not the easiest thing in the world to kind of read, to look at, and understand. So another common way of working with this data is to turn it into 3D. And that's what I wanted to do. I wanted to take this HiRISE raw data and make lots and lots of little 3D models, basically. So I first wrote an application which works on your desktop. I kind of researched the data. I researched what was coming back to Earth and found out a way to convert that black and white image into this 3D model that you can see in front of you. And I put it on the web for everyone to freely download. If you've got a Mac, you can do it yourself. And when I did that for every single model, and I think at the time there were about 300 little tiny models of Mars available, I made them all into these 3D models, and I created a website called Ario Browser. So what I quickly want to do is hop over to Ario Browser and show you what's over there. So I'm going to hop over there quickly. So this is Ario Browser. It's at ariobrowser.com. And when you go there, you see these two sides to the screen. You've got this left-hand side with this big, long list of, at the moment, 560 different models of Mars that are available. And on the right-hand side, there's a video of me explaining it and some instructions at the bottom. But if we go and find that image that I just showed you a second ago, it's called Crater Cut by Cocrates Chasma, which is an amazing name. I can click that. It will load in that right-hand section, and very quickly I'll be presented with a 3D model that I can rotate around and explore. I can bring back that color gradient if I want with this button here at the bottom. And that gives me this little gradient down here that tells me that the lowest part is minus 4,000 meters below the surface of Mars. And the top part is 2,500 meters above the surface of Mars. So there is basically a 6,000 meter drop from the top to the bottom of this little model. It's a huge drop. It's a very dramatic little bit of Mars that is much, much easier to visualize and to see in this 3D format. There's a few other things you can see here. So we've got this grid in the background. This is just a way of knowing how big the model is. So this grid from the left side to the right is currently, if you look down here, 20,000 meters wide. This is 20 kilometers from left to right. And if you have some of those kind of fancy red and blue 3D glasses as well, there's also a 3D mode that you can turn on and start viewing this data inside of the viewport here. And this works on your laptop, on your computer, and also on your phone too. And the amazing thing about this is that it's very easy to then go in and start viewing the entire data set. And this has been a big, big important thing for me. The idea of increasing the accessibility of the data. I always use my mum as an example. I always think if she can go to a website knowing nothing about what the HiRISE mission is and start zooming around 3D models, then I've done a good job. And she can, which I'm very, very happy about. So there's one other thing I want to show you in here very quickly. As you go through this list and start to explore the data and discover different bits, you can find some really amazing stuff. And this is my favorite model on the entire site. If we take a look at it from above quickly, what you can see is that we have this kind of valley down which there's this obvious kind of flow of something ending in this kind of pool or this kind of lake thing at the bottom here. And this is suspected to be a glacier on Mars, which again just blows my mind. It makes me amazed at what we can tell from a completely different planet in this data. It's these things that you can pull out of them that are so exciting. So that's Ario Browser really. And what I'd love you all to do is go and play with it, play around with it. You can download the models in here as well. So if you click on these little icons here, you can download this model and also download a 3D printable model. So I'll quickly show you that because I did do some 3D printing. So I printed Gaza crater, which looks like this. So it's quite nice holding that tiny little bit of Mars in your hand. And that is the Ario Browser project. So at this point, I'd finished. This took about a month to do. And I thought, okay, that was really fun. I really enjoyed it. I know this is something that I feel passionate about and I want to keep doing, but I want to work on a slightly different data set. I want to do something that's a bit more image-based as opposed to being 3D-based. And so I thought, wouldn't it be kind of fun to take kind of image data set and allow you to view the whole thing in your browser in 3D around a version of that planet that it was taking photos of. And when I was looking for data sets that might kind of meet these criteria, I came across the Mission Juno website. And this is an amazing website put together by the Juno team that outlines a lot of things about the Juno mission, stories about all of the instruments, how it actually got into orbit around Jupiter. But importantly on this site, you can also download a whole bunch of raw data from one of the instruments, JunoCam. JunoCam is the instrument onboard Juno that's most similar to the camera that you have on your phone or the camera that you might have at home. It's the one that takes those visible light images. And the data that's available is usually presented in a few different ways. So on the right here, we have a normal image, this RGB image. And all images that appear on your computer screen are RG and B images, which means they have a red bit, they have a green bit, and they have a blue bit, and they're all smushed together, and you end up with your final result. And that's what we're seeing here, the individual red, green, and blue parts, and that final result on the right-hand side. But also, we're presented with that raw, spiky gray image from earlier. Believe it or not, these two represent the same set of data. This is the same view of Jupiter, but just seen in different ways. And I very quickly realized that this bottom part here, this raw part, was kind of fascinating. And the problem solving part of my brain kind of jumped at the chance to kind of head into it and trying to figure out exactly what was going on with that data. And this kind of brings me to the point that a lot of this work, a lot of processing raw space data is trying to research and figure out and understand exactly what you're looking at. Because only once you understand it can you start processing it in a way that might make sense. And occasionally you're presented with a really big problem. So in this case, you know, trying to turn this gray spiky image into a nice picture of Jupiter is quite a big problem. And so what you try and do is you try and split that up into these individual tinier problems. And then if they're too big, you split those up and then split those up until you're faced with kind of just a series of very small steps, each of which is quite doable and quite achievable, but add up to a greater whole, add up to that final beautiful picture of Jupiter. So in this case, I knew that I needed to understand this image. So I did some research and I realized that Juno is something called a push frame camera. So this basically means that Juno, the spacecraft, we imagine that this is Juno, is basically front flipping through space. And it's orbiting Jupiter about once every month and a half. And as it front flips, as it gets close to Jupiter, instead of it trying to figure out exactly when to take a photo of Jupiter and frame it really nicely, what it does is it turns on its camera and it just starts taking photos, one after the other, as it rotates through space. Now, when it does that, each photo that it takes, it puts in a line and it sends that combined set of images back to Earth. And that is what we're looking at here. It's not one photo, it's lots of individual photos taken by Juno as it rotated through space. And so there's not one image here, there's actually 24 images here. Now, if we zoom in on this, the bit that actually contains Jupiter, you can see, let's say we look at image number 12, there's still something weird about it. It's kind of split into these vertical lines. And that top line, that top part of it is not smooth as you would expect from a planet. It's kind of jagged, right? Well, I did a bit more research and I found out that each one of these separate sections is split into those three R, G, B, red, green, and blue colors. So that each part of the camera can capture that basically section of light, really. And the reason for that jagged bit at the top is because each one of those sections has a slight gap in between it. There's a bit of a gap between the red and the green, and a bit of a gap between the green and the blue. So now at this point, I felt like I kind of understood exactly what was going on here. So in order to process it, I knew that I needed to separate up that big long image into multiple different images, all of the images that were captured. I needed to add back in that red, green, and that blue color in order so that we can eventually combine it together into a full color image. And then I needed to recreate exactly what Juno saw. I wanted to make an animation that if you just had a regular camera on Juno whilst it was rotating past Jupiter, it would basically capture this animation. So this is kind of where my visual effects background came in very handy, because this kind of processing, this image processing, is very, very common. Every film you see in the cinema, every kind of TV show you see on television will probably use this process called compositing. And you can kind of think of it a little bit like Photoshop, where you take lots of images and you add them all together in a certain way. Compositing is the same thing. It's just bringing in all of these different images, but maybe a bit of 3D data as well. Maybe there's some scripting involved too. And it's just combining all of these really big data sets into a final image. And it turns out that that was a perfect way of processing this Jupiter data set. So in doing this, I'm not going to go into this too much, but essentially it's the same thing I was saying a second ago. You take this big long problem and you split that big long problem up into these separate chunks, each of which is much easier to achieve, and each of which moves that data on into the next problem and then into the next problem. So you're slowly getting towards the end of the problem as you go forwards. This is what that compositing work looks like in visual effects. It looks quite scary. You've got all of these blocks and all of these lines, but essentially what this is doing is separating up that image, adding in those colors, and making that animation so we can see what JunoCam would have viewed. And when we do that, we end up with this image here. So this is exactly what JunoCam would have seen as it rotated through space and went past Jupiter. And if we slow it down and I make it a little bit more contrasty, you can start to really pull out that kind of storm detail on the surface of Jupiter and all the clouds and all of the cyclones and the craziness that is going on the surface of Jupiter, which is just amazing. And it's here when you know that you've done it kind of right, which is really good, and you have you know, a nice celebration. And the next step from this is once you've got all of these separate images, you can try and then combine them to make that full color image. Now, as luck would have it, because Juno rotates kind of steadily, we can do something quite simple, quite surprisingly simple, to make an image of Jupiter. We basically take all of the frames of that animation, put them all next to each other in a line, and slowly decrease the distance between them. So if I do that here, I've got this distance of 800 pixels. If I bring them slightly closer together and slightly closer together, and as we do, we add up all of those pixels, the reds add to the greens, add to the blues, we slowly get, if you get the right distance, this picture of Jupiter. And at this point, we can absolutely congratulate ourselves because we've taken that raw image and we've made it into something that looks very presentable and really quite awesome. The interesting thing is that to do what I wanted to do, to basically take this image and present it in 3D, I needed to go even further than this. Whilst this is brilliant, I needed to add in extra space data. I needed to add in extra raw information to find out exactly what the 3D structure of this was. And so I did a lot of coding that looked an awful lot like this. I took 3D data from NASA that tells you exactly where every single thing is in the solar system. If it's a moon, if it's a comet, if it's a spacecraft, you can tell exactly where it is at any time. And I brought those into my visual effects application. On the left here, you've got the green, which is Jupiter. You've got the camera, which is our Juno cam as it's animating past it. And on the right, you've got what Juno cam can see. Then I combined this 3D data with the 2D data that I had previously, which looks a little bit like this. You can see those red, green, and blue strips animating over the surface of Jupiter. And when you take a photo of this, essentially, you end up with this big progression of those stripes across the surface, and combining them all back together, you end up with this picture of Jupiter. Now, this looks very similar to the picture we made a second ago, but this picture took about 5 months longer to create because I had to figure out all of the different bits, and it was a lot more complicated than I thought it might be. And if we compare them, you can see they're very, very similar. The one on the top is just the 2D version we made very quickly. The one on the bottom is the 3D version that took me a very, very long time to make. But the really good thing about the bottom one is that it comes with that camera, that 3D camera, representing exactly where Juno was in 3D space. And with that, I then produced this website called Juno Observer, which is what I want to show you now. So I'll quickly hop over into that and take a quick look. So if we hop over to Juno Observer, it looks like this. You need to select an image from the bottom of the screen. So I'm going to run in and choose something. Let's choose this one's pretty good. And you're presented with all of the data from the JunoCam project in 3D, and you can zoom around it. You can look at it from any angle. This blue path is the path of Juno as it flew around Jupiter. Now, at the moment, it's a bit curved for various reasons because I've essentially allowed you to make time lapses of the surface of Jupiter, and it involved slightly making that curve a little bit warped as opposed to straight as it would be in real life. But the good thing about this is it means that I can zoom in on the surface of Jupiter, at any point and start exploring all of these storms and these structures and these clouds on the surface of Jupiter for myself at the full resolution of the raw data. I can do this on my phone. I can do this in my browser. Yeah, I'm really very proud of this project. I love it a lot. And I think, you know, every time I come into here and I zoom around and I look at these different clouds, I get amazed at what's going on. And I get amazed at looking at all of these different kind of cyclones and all of that stuff on the surface. So yeah, I'm really proud of this project, and I'd love you to all try it out as well. So to finish off, I have a couple of extra little things to say very quickly before we pass over to the questions that you might have. So first of all, I want to talk about how you can potentially get started with some of this. If you're interested in creative coding, I absolutely recommend this channel on YouTube. If you've never done coding before, it's really good. If you have done it before, it's really good as well. It's called The Coding Train. It's by a man called Dan Schiffman, and he is absolutely brilliant at explaining what creative coding is how you can get started. And in fact, the next visualization I'm doing, which I'll show you a quick look at in a second, is going to use the language that he's teaching you in this course. If you're more interested in doing the art side of it, the non-coding side of it, you could go to that Mission Juno site that I showed you earlier. You could download any of the data from that, put it into something like Photoshop, and try and make your narrative, try and make your version of that image. If you want to zoom in on the great red spot, or you want to look at a particular cloud and try and make it as dramatic as you can do that, and you can post it on the Mission Juno site for other people to see, and there are thousands of images on there that you can take a look at. You can also browse the entire raw data set from the NASA missions, at least, on a site called the PDS Opus. So if you're looking for a fun project where you get all of the pictures of Saturn, this is a really good place to go and find them. And there's data from 50 years of space exploration on this site that you can go in and search and look at. And it's a very good way to spend a lot of time looking at very cool space things. So with that, I want to talk very, very quickly about my next visualization. It's based around Kepler, which was a space observatory that sadly retired last month, but it found 2,327 exoplanets, planets that exist orbiting very, very distant stars. And what I want to do is I want to visualize that in 3D again, in your browser, on your phone. But what I thought would be kind of fun would be to do it step by step, week by week, and release a tutorial video, release all of the code. So if you're interested in following along with me and asking me questions and kind of learning about how I think about making a visualization, that's a really good way to go. I did a quick prototype of it just to show you what it might look like, and it might be something a little bit like this. That pink bit is our sun, and every white spot is another star that has planets around it. It's amazing to me that this is something that exists, and I think if I can make a nice visualization of this that makes the accessibility of the data even higher, that would be a really good thing. So yeah, I think that's it. I'm gonna leave some links on the screen here to my visualizations, that place where you can browse the raw data, and also that coding train as well, that YouTube channel. But if you have any questions, if you have anything to ask, let me know. And if you don't think of them now, you can always find me at those 2 links at the bottom of the screen there too. So yeah, thank you very much for listening. I hope that was interesting. And I hope it's inspired some of you at least to go and try and play with some of that raw data. So yeah, back to you, Nuno.
Matt, thanks so much for your presentation. That's brilliant, your work. It's awesome, really
Thank you
exciting.
so much.
It's incredible what you have done and what you have achieved.
Thank you very much. It's such an interesting data set to work with. It's a pleasure to work with. You know, it's super fun.
And I'm sure that you are inspiring now lots of people, at least the people that are watching this webinar, and people that will go to watch it later on our YouTube channel. You're going to inspire lots of people with your amazing work.
That's very kind of you to say.
Yeah, no, really, really. I'm not trying to be nice here. It's really fantastic.
It is very nice, though. Thank you.
Okay, so we have time for a few questions. We already got some from people that are watching us. Okay. Maybe I can read them for you and you can answer. You can take your time. We have around 25 minutes still, so it's okay.
Yeah, absolutely.
Okay, let's start by this one from Nim Teresa from the UK. She says, "It is awesome. How do you get all this data? Is it free? If free, can you use them as you wish?"
Yeah, that is a really good question. And it's one of the things that really surprised me about all of this so much. Sorry, I just realized I'm covering up some of those links. So it surprised me so much. Yes, it's all free for you to use. All of the Jupyter stuff, you can do whatever you want with it. If you want to put it on a t-shirt, once you've made something that looks really cool and sell it to your friends, you can do that. You know, you can do anything you want. And that makes it such an amazing data set to work with, because the possibilities really are endless at that point. You know, you can afford to choose the thing that you're really interested in and work with just that little bit of data and do the thing that you find exciting. You know, that's the cool thing about working with this space data. Yeah, it's all free, all able to do whatever you want with.
Okay, great. This is related to another question from Anita Simak.
Okay.
She's asking if the photos from the mission Juno site are copyright free because she wanted to use those pictures to print them for students. Is it the same thing? I suppose all of them are copyright free, right?
Yeah, so what I usually do is whenever I share them on the internet, I'll put a little credit on them. And I'll say that, the data came from NASA, it came from the people who made the camera, those kind of things. But I know people who have definitely printed them out, definitely made posters and used them for education, used them for whatever. Definitely, yeah, it's free to do with that. The Mission Juno site is fantastic for that, and it will walk you through how to print them all and how to get them all. So yeah, definitely recommended.
Sure. So to be on the safe side, you just should give the reference to the source, and that's it, and you can use them freely.
Absolutely,
Right?
yeah. I think it's something that they ask you to do. It's not, I don't think they'd come after you and kind of, give you a telling off if you didn't, but it's nice to do. It's something that amongst the space community, when people make images, they obviously put quite a lot of effort into a lot of them. And so it's quite nice to, give that credit where that's possible.
Sure, definitely. Okay, so we have another question from André Ferreira Freitas. I believe he's from Portugal.
Okay.
He says, amazing work. Where can I find the NASA information about the objects in the solar system?
That's a very good question. So there are two places you can go, or there's one place you can go, and if you're really into coding, one very coding thing that you can do. So what I used is something called SPICE, SPICE, and it's a very technical way of finding out exactly where things are in the universe. There's a slightly easier way of doing it, which is a website called Horizons, which you can go to, and you can basically put in, okay, where is, the InSight lander? An hour before it landed on Mars last night, where was it? And it will give you back some coordinates and some times and things like that that will tell you exactly where it is. And the good thing is you can download those results and use them in your creative coding, use them in your projects. So perhaps we can put some links together, Nuno, and we can share those with this video.
Sure, definitely. We'll do that. We'll put those links in the description of the video in our channel, okay?
Perfect. Yeah, that sounds like a good plan.
And we have another question from Portugal as well, Inês Fatima, and she asks if this visualization is a real translation of the data you get, or if you have modified a little bit. She asked this because many astronomy images are more artistic impressions. So
right. Yeah, that is a very good question. So that is something that I think a lot of people who actually do the processing themselves kind of slightly struggle with, and finding where the line is between showing something that's real and showing something that's slightly arty. On Juno Observer, I purposefully took the route of trying to show it as real as I could. I have done one or two things just to pull out a little bit of the extra detail in the clouds and things like that, but not very much, not compared to a lot of the images you see. My goal with the site is to allow you, the user of the site, to do that work yourself, to go in actually on the site, to choose an image and to add contrast, sharpen it, change colors, do whatever you want to tell your story about that image. I don't want to do that as the person supplying you with that data. But obviously there is that thing of, because I have put it through this long process to get it to look like a picture of Jupiter, you could say that it is not necessarily entirely exactly as captured. It's a very good question. It's a very hard question to answer. But I think that, there's lots of very processed, color corrected imagery. And I think that definitely has a place. And I think it's brilliant. And a lot of my good friends do it. And they're brilliant at it. But at the same time, seeing it exactly as it is, I think, is important for context, to know that Jupiter is kind of a murky ball. It's not this very contrasty black and white thing. So it's probably the best answer I can give for that, I think.
No, exactly, brilliant. And in fact, sometimes some of the instruments that are used for space exploration they observe light in other wavelengths that are outside the visible part of the spectrum. So we have to
Absolutely.
translate those wavelengths to visual wavelengths that you can
Of
see.
course.
In that
Yeah.
sense, of course, it's an artificial image, because if you look to the object with our bare eyes, we will not see those colors. But
Yeah.
all the information is there. It's scientifically correct.
Yeah, that's completely true. I mean, that one of the next things I'm doing on Juno Observer is processing data, raw data from one of the other instruments on NASA Juno. So while JunoCam is looking at visual light, like your normal camera, like Nuno says, there are other things on there that look at other things. And I'm currently processing one called GIRAM, or GIRAM, which looks at infrared. And obviously we as humans can't see infrared, so you have to try and process it some way that we can make sense of. So that art versus real world line, again, is very interesting at that point too.
Great. We have another question. In fact, this one was sent by Jean Branco from Brazil.
Okay.
In a video, she recorded the video, but unfortunately, I think we cannot show it because we don't have the sound coming out. So
Right.
I think I'm just going to read the question. And she asks, how did you change the visual effects area to work with raw space imagery? What motivated you, and what is it like working in this business?
These are very good questions. These are excellent questions. What motivated me? So in all honesty, I was in visual effects for about 10 years. I still do a little bit of work in visual effects, and I love it. I find it super interesting. But I realized in the last couple of years that the skills that I had learned doing that one very specific visual effects thing were also useful for doing other things in other areas of the world, of business, of science, of whatever. And it turns out that this creative coding thing that I mentioned at the end can be applied to a whole range of different industries. And I personally really love space. I've always loved space. I've always been fascinated with it. And when I realized that you could get that raw data, I suddenly found that I could, use the skills that I have, those creative coding skills that I'd learnt in visual effects, to process it. And that actually it was kind of similar to the work that I had been doing anyway in visual effects. And so that was very exciting and very fun to see. So that's kind of how I made the switch. At the moment, the visualizations I'm doing are really kind of just for me. They're ways of me doing the work. I'm not, working for the ESA, or I'm not working for NASA or anyone like that doing this. In an ideal world, maybe one day that would happen, but we'll have to see. But I have to say that just working with the data and being inspired by the data and being inspired by the amount of work that goes into capturing it in the first place, it's really very, very satisfying to do. And, what I'm learning is very thrilling, and it's very good for me, my personal development, if you want to think about that. But it's also cool that I can put something out into the world that hopefully might make, a few extra people kind of see this data as well. So I hope that answers the question.
Yeah, definitely. Fantastic. Let me check if there is any other question in the chat window or the Q&A app. No, I cannot see any more questions. We still have a little bit of time. So if you have more questions, maybe guys, you can type in your questions and Matt will be glad to answer them.
Absolutely. There are no silly questions when it comes to this stuff. Definitely.
Sure.
Yeah.
In fact, I have just one little question.
Of course.
Related to that first app that you showed. Is it possible to compile it in Linux and run it in a Linux operating system, or is it just exclusively for Mac? That's
a good question. So at the moment, it's sadly just Mac, but it is on my list to make a version of it which we can use everywhere. Yeah, it would be nice. I've had a couple of requests for that because it is kind of nice to use. So yeah, it's on my list, definitely.
I will look. I will wait for that.
I mean, the other thing we could ask people as well is if or something to think about. Maybe we don't have to answer it now, but it'd be interesting to maybe hear after time, like what people would think would be interesting things to do like this. What other projects would be interesting, That next Kepler project that I'm doing is something that I've thought of that I think would be really interesting. But there's nothing saying that, one of the people listening here couldn't suggest something, and that could be the next project that I work on, So I'm really keen on being quite, it being quite a community thing, you know, and working together through stuff like this. So yeah, definitely think about those things. And if anyone has any suggestions, do let me know at some point.
Yeah, great. There was another question also in the Q&A app from Alexei Pace. He says, great explanation. And
Thank you.
he wants to know if the spacecraft has 3 cameras, one per channel, RGB.
Great question. All very good questions. It doesn't, no. So if you take a look at your regular camera, you basically, inside of that camera, you have a sensor. And that's the thing that will capture the light, essentially. And in normal photography, you might put something on the top of the lens that would affect it in some way, that would affect the light getting into that sensor. On JunoCam, instead of doing something to the lens, what they did, essentially, was put 3 colored strips on top of that sensor. So you have a red strip, you have a green strip, and you have a blue strip. So it is a single camera with a single sensor, and the light comes in through a single lens, but then it hits these colored strips, and that's what gives us that red, green, and blue separation.
Okay, great. That's it. Let's see if we have any more questions in the chat window. Apparently not. So if you don't have more questions, I think we are going to finish our webinar for today. Thank you so much, Matt. It was really wonderful to see your presentation and to have a contact with your work. Definitely, we are going to follow it in your website, and we'll wait for your next endeavors. And thanks a lot for accepting our invitation and for participating in this November webinar, Europlanet webinar.
Of course, thank you so much. I mean, I'll just say again very quickly, like, thank you to Europlanet for having me, but thank you to everyone who listened, and thank you to everyone who asked an awesome question as well. You guys are on top of this. It's good to see.
Thank you. We'll keep in touch. Okay, as for you, thank you so much for attending and participating in our webinar. Don't forget to follow Europlanet on Facebook and Twitter, and feel free to ask your planetary questions there. You can also watch this video and previous ones on the Europlanet YouTube channel. You can find more information about this webinar in the Europlanet webinars and Galileo Teacher Training Program web pages. The links will be available in the description of the videos in our YouTube channel. And this was the last webinar of 2018. We will meet again in January 2019. Okay? Hope to see you next time. Goodbye, and Nuno out.